Physicists love triangles, but not as mystic devices used to divine a correct answer. I'm the head of physics in my school, and this is the poster I have displayed in every lab. Now, I know this is a controversial topic, and that there are some people who are big supporters of formula triangles and others who are adamantly opposed to them. And there are then some educators who sit on the fence and talk about the positives and the negatives. Well, I'm adamantly opposed to them, and I'm going to tell you why. I've seen far too many students who, in exams, don't really know what they're doing. And so maybe they do something like this. They draw a triangle, and then they'll put some letters in that triangle. Perhaps they'll put a V and an I and an R. And they'll use a peculiar method where they cover one of the variables to decide what to do with the rest. The problem with this method is that it doesn't teach algebra at all, which is an absolutely essential tool for so much of the physics that we do. And I've seen students who don't really know what they're doing, and so they just think if they put the letters in this magic triangle and cover things up, it's going to work. And of course that's nonsense. That's not how these magic triangles work. And so at GCSE level there are 23 equations that students have to learn. And if they have to learn the peculiar magic triangle as well as these 23 equations, that's just extra for them to have to learn. But if they remember the units, which is usually the easiest way to construct the equations, and some basic rules of algebra, there's far less for them to have to remember. Let's take the example of the equation for density. If you're asked to calculate the density, you might, if you're lucky, be told the unit. But you might not be. But you'll be told the unit of the mass and the unit of the volume that you're using. And so you might end up with a unit for density like this. And then you'll start thinking, well, what was that magic triangle I needed? Stop it. Just look at the unit. This part is the unit for mass. This part is the unit for volume. And that slash, the per, means divided by. Kilograms per cubic metre is mass divided by volume. Now that's not an equation yet because there's no equal sign. So we slip a little equal sign here and we get told that's what density is. And I'm going to use the Greek letter rho for density. So I didn't have to remember the equation. I figured it out from the units. Now what if I had the mass and I had the density and I wanted to calculate the volume? There's no magic triangle here. I just used the basic rules of algebra. Right now the volume is a denominator and I want it as a numerator. So what I'm going to do is multiply both sides by the volume. That way the volume on the right hand side cancels. Now I want to get rid of that rho, that density, so I divide the right hand side and the left hand side both by rho. And it's the same rule. What we did to one side we do to the other, and because rho's cancel, I'm left with just the volume. Now, the rules here were quite straightforward, and I could manipulate them to conjure up some equation for volume without having to guess which way round the triangle went. Now, students might say to me, but sir, it works. So why not use it? Why not use some sort of system that helps me get the right answer? And the answer is because it will not always help you get the right answer. This is a GCSE physics equation, and you are going to struggle to put that into a formula triangle. There's always someone who thinks they're being clever and does something like this and giggles away to themselves. There's no better. All you've done is draw a triangle. There's no mystic device here where you can cover one variable and do something with the other. If you want to get u out of this equation as the subject, you've got to do algebra. And it's the same rules for the simple equations as you'll apply to these more complex equations. But if you haven't practiced those rules thoroughly with the simple equations, then you won't have them at your fingertips to use with these more complex equations. And you might be able to convince yourself that you can put 4-term equations into a formula triangle, but all these equations are GCSE physics equations and it just won't work. I've seen textbooks that teach formula triangles. I've seen other YouTube videos where they promote how wonderful they are at helping students. They hold them back. The mathematical skills you'll be using in GCSE physics, A-level physics and beyond. And if you don't want to take physics, okay, you'll use those same skills go into any sort of field of engineering or medicine where you have unit conversions, veterinary science, any sort of field in chemistry, biology, any of the sciences or mathematics, you'll be using the same basic rules of algebra. If you haven't learnt those rules of algebra because you've been relying on a formula triangle as a crutch to get you through, then you're putting yourself behind, you're holding yourself back, and it's going to cause you problems later down the road. And you may say to yourself, well, I've got no interest in any of the sciences whatsoever. And while I'm sure that's possibly true for some people, oh, I can't understand it, that would be really sad. It's so sad that you would want to reduce something which is logical and consistent down to a set of arbitrary rules you don't understand, covering up a variable in a magic triangle. You don't understand the mathematics that underpins the science. So you're reducing science to just a set of beliefs rather than something where there is evidence and logical consistency that we use all the time. That's the whole point of science education in secondary school, is to show young people this world of rational thinking and evidence-based understanding. And the things that frustrate me, apart from the textbooks and apart from the YouTube videos and other revision aids where these triangles are lauded as wonderful things, is that students are even taught this in primary school. Now, I work in a grammar school, so I have pupils that come through who have done the 11 plus, and they've been trained for the 11 plus, and they're very, very good at mathematics. And they turn up to me and they're showing me these various methods that are just modifications of the formula triangle for solving algebraic problems, but they don't understand algebra, so we have to reteach it. And it's no more difficult. It's so few rules. Just what you do to one side of the equal sign, you do to the other side. And you do the opposite of what's being done to the variable to free up that variable. The rules are simple, but this formula triangle persists. Not in my labs. It's banned in my labs. I will not allow it. And when I see students using formula triangles in exams, as an examiner of A-level physics from other schools, I don't know what schools they go to, I'm not supposed to know. But when I'm examining other students' work and I see these formula triangles every now and then crop up, and these are advanced level physicists, it really makes my heart sink, because they have the capacity to learn algebra, practice algebra, and yet they're still leaning on this crutch which might have helped year 5s get through an exam without knowing any mathematics. It's not suitable for a subject like physics, chemistry, mathematics, in which mathematics underpins everything we do. Learn to rearrange equations properly. Just a little investment of effort, and everything else in physics will be much, much more straightforward. But if you liked that rant and you want to see more, please don't forget to like the video, subscribe, and also ring that little bell, because that way you get notifications when there are new videos or when I go live. Thank you very much, and I'll see you next time.